Okay, welcome back to SAT Math Week 5. This week is part 2. There are 3 sections today, and we'll be going over 1 variable data, 2 variable data, and probability. Okay, they're not super big sections, so I put them all into one lecture. And starting off with 1 variable data, we have this question here that says data set A consists of 10 positive integers less than 60. The list shows 9 integers, and the mean of these 9 is 42. If the mean of the data set A is an integer that is greater than 42, what is the value of the largest number from the data set A? Now, the wording of this question might confuse you a little bit, but essentially we're asking for the number, the 10th number that can make this data set's mean from 42 with the 9 integers to 43 with 10 integers. Now, in this case, again, x is the 10th integer, and we have our mean. So this comes from all the numbers from data set A, the 9 integers, plus that x over 10, and we need that mean to be over 42, aka 43. Now, in order to find that, we do know that x must be a multiple of 10 greater than 420, or 378 for that matter, to make it 430. And we do know that x has to be less than 60 because the 10 positive integers all have to be less than 60. So we know that it can't be 42 because it won't actually make the mean greater than 42. And it can't be 62 because it goes over it goes over 60. So in order to make our data set 430, because we are dividing by 10 with the 10 integers, we find that x equals 52. Now, once we have 53, we do know that 52 is the largest integer from this data set here. Okay, this question here. A data set of 27 different numbers has a mean of 33 and a median of 33. A new data set is created by adding 7 to each number that is greater than the median and subtracting 7 from each number less than the median. So which one does not have the same value in the original and new data sets? So we have 13 numbers less than the median, 13 numbers greater than the median, and 1 equal to the median. So these 13 numbers will, 13 numbers on both sides will change. And the mean and median are both 33 in the original data set. Now, if we actually keep in mind and account for that plus and minus 7, we'll find that the total sum does not change because we are adding each number by 7 and subtracting by 7. So our mean and median will actually also just stay the same, but the numbers that won't will be the range. And that's because our total data set is expanding, meaning our standard deviation will look different because the smallest number is now 7 units smaller and our biggest number is 7 units bigger, meaning that will change the standard deviation. Okay, this question here, fairly simple. Students get this wrong because they just don't know how to read these box plots. But when you look at the range here, we're not looking at the actual box, we're looking at the tail and, the whiskers. Meaning, for class A, we need to find the range of the outermost and the lowermost. Meaning, we have 5 minus 0 because that's where the graph ends. Meaning for class B, we'll also have 10 minus 1 because that's when that range ends as well. And we look at the difference between the positive difference between the ranges of the two classes. We'll do 9 minus 5, which equals 4. Okay, again, this one is also fairly simple. as long as you know how to solve this, should be a free point. The mean score of 8 players in a basketball game is 14.5. The highest individual score is removed. The mean score of 7 becomes 12. What was the highest score? Okay, easiest way to do this, you just find out how many numbers are actually in that total data set. So we'll do 14.5 times 8, get 116. Same thing for 7. 7 times 12 equals 84. Once you subtract, we'll find that it was 32, and that is the highest score in this game. Okay, now we move on to two variable data. So we have this question here that shows an exponential model shown in the formula y equals a times b to the x power, and we have to find which is the closest to this value of b. So again, we use this formula here, and we can use 2 points to figure out what to estimate b as. And the 2 points we can pick are the starting value and a value we know aligns well with the x and y, and that is about 10, 20. So we have these 2 points here. We can estimate the origin to be about 126, 125 should be fine. And using our endpoints, like I said, we can estimate that decay factor, which we do 20 over 126 times, to the 1/10. That comes from the 20 over 126, and that exponent comes from the 10. So we'll just do 1 over 10. And we'll actually round to 0.83, which is our answer here. So this question here, we have line of best fit, and we have to actually explain what the line of best fit actually does predict for this equation. So they give us the equation y equals 0.096x minus 0.488. Now, again, we have to keep in mind what they give us in units. And they give us slope as 0.069 years over minimum wage, meaning we're working with minimum wage, and that slope is the direct number of money changing per 1 year. Meaning after 1 year, we'll increase $0.096 per hour. So, self-explanatory. That means each year between this time period, the average increase in minimum wage is $0.096, the slope. Okay, line of best fit here. The scatter plot shows the ice cream sales in dollars and the temperatures T in Celsius on 12 different days. We have a line of best fit and what could be used as the line of best fit. So again, we're estimating 2 points here. We're estimating 12,480 and 24,880. Now these numbers don't have to be perfect. We are just estimating, but it is better to try and be as accurate as possible. M equals 880 minus 480 over 24 minus 12. And we'll actually estimate that to about 33. So that is our slope, and we'll plug in back our original values, which is 12,480. Once you plug that in and search for b, you'll find that b equals 84, and our answer is d equals 33x plus 84. Okay, on to probability. We have this question here. Human blood can be classified into 4 blood types and is also characterized by plus or minus of that rhesus factor. Now this table shows the distribution of a group of people. If one of these people whose rhesus negative is chosen at random, what's the probability that the person has blood type B, which is given as 1/9? What is the value of x? So how to find this? We just add up everyone that has a rhesus factor of the minus, and you'll just simplify that to 10 plus x. And 2 of them are type B. So we'll do 2 over 10 plus x, because that's the probability of picking someone with type B, out of everyone who has a minus blood type, and the probability of picking B minus out of everyone who has a minus blood type. And we do know that the probability is 1 over 9. So we can just equate that and cross multiply, get 18 equals 10 plus x, and x will equal 8. Okay, we have this question here. A grove has 6 rows of birch trees, 5 rows of maple trees. Each row of birch trees has 8 trees 20 feet or taller and 6 trees shorter than 20 feet. Each row of maple trees has 9 trees 20 feet or taller and 7 trees shorter than 20 feet. A tree from one of these rows will be selected at random. What's the probability of selecting a maple tree given that the tree is 20 feet or taller? Okay, this just shows us that we don't really care about how many trees are shorter than 20 feet. And again, we are searching for the probability of searching a maple tree out of, maple and birch trees. So in order to find that, we can do number of maple trees taller than 20 feet over total number of trees over 20 feet. Birch trees, 6 times 8. Maple trees are 5 times 9. Total is 93. And we know that maple trees is 45. We'll just do 45 over 93, which simplifies to 15 over 31. Okay, last question for today. There are 83 million internet subscribers in Nigeria. The major internet providers are MTN, Globacom, Airtel, Etisalat, and Visafone. By 2015, it increased to 97 million. If an internet subscriber in Nigeria is selected at random, the probability that the person selected was an MTN subscriber is 0.43. There were p million MTN subscribers in Nigeria, and to the nearest integer, what is the value of p? So again, these are nearest integers, so we are just rounding to a whole number here. Similar to the last question, in order to find the number of MTN subscribers, we have to divide them by the total. And they tell us that there are p million. So we'll do million over the total number of internet subscribers, which is 97 million. And again, we'll just do p times 1 million because there are p million. So once you divide that out, you'll get p over 97 equals the probability, which is 0.43. And once you do multiply, you'll get p equals 41.71, which rounds to 42. Okay, again, these are all pulled from SAT questions. If you have any questions, you can feel free to leave them in the comments below. And we will, again, have a final lecture for week 6.